Hello and welcome to Maths with Jacob. This lesson will focus on intersecting lines. Following on from the previous lesson, we will now show how to draw two lines on the same number plane and find their point of intersection. Let's look at example 1 to see how we do this. Find the point of intersection of the lines y equals x plus 1 and x plus y equals 5. First, we draw up a table for each equation. So here's the first equation, and if you remember from the previous lesson, when we draw the table we can choose whatever x values we like, and after we've done that we can then determine the y values using the given equation. So when x equals -1, y equals -1 plus 1, which is 0. When x equals 1, y equals 1 plus 1, which is 2. And when x equals 3, y equals 3 plus 1, which is 4. So these are the numbers. That's the completed table for this equation. Now the second equation was x plus y equals 5. Excuse me. And I've chosen for the x value 0, 3, 5. Remember, you can choose whatever numbers you want. When x is 0, y will be 5. When x is 3, y will be 2. When x is 5, y will be 0. So now we can extract the ordered pairs or the coordinates for this line here. 3 coordinates, -1, 0, 1, 2, and 3, 4. Okay, so for that first line, right there it is there. -1, 0, 1, 2, and 3, 4. So that's that line there. Now we have 0, 5, which is there, 3, 2, which is there, 5, 0, which is there, and that gives us that line. When we draw those two lines, we can see very clearly the point of intersection. And that's 2, 3. So that's where the two lines intersect. And what that tells us is the x value of 2 and the y value of 3, they work for this equation and for that equation. That's what happens when you find a point of intersection. The coordinates work for both equations. Let's look at another example. Second example, find the point of intersection of the lines 2x minus y equals 3 and 2x plus 3y equals 7. So first we draw up a table for each equation. So there's the first one. I've chosen -1, 1 and 3 for the x values. And after we substitute each of those x values into this equation here, we get these resultant y values. For the second equation, which is this one, I have chosen those x values. After each of those is substituted into this equation, okay, we get those resultant y values. Okay, so that's very important to remember that. You just take your time, substitute each of the x values individually, and that will give you each of the y values. All we do then, we have 3 coordinates, x coordinate, y coordinate, sorry, we have three points if you like. That's the x coordinate and the y coordinate. That gives you 1 point or an ordered pair. So 3 sets of ordered pairs. Okay, so those ordered pairs here they are, the 3 of them. That gives us that line. Those ordered pairs there, here they are here. That gives us the second line. You can see clearly there is the point of intersection, which is 2, 1. The point 2, 1 will work for both of these equations. Let's quickly check that. 2, 1. 2 2s are 4, minus 1 is 3. That works. 2 2s are 4, 3 1s are 3. 4 plus 3 is 7. So that works there. So that is the point of intersection. So this video has shown us how to find the point of intersection of two equations, and all we have to do is draw up a table for each equation, and then we have to work out some ordered pairs, and then we plot those points on the number plane. We draw each line, and we should clearly be able to see the point of intersection for each one of those lines.